In 2013, something impossible happened. A radio telescope in Western Australia picked up a signal from deep space. Not a burst, not a glitch, a perfectly repeating pulse. Every 18 minutes, exactly. It had been doing this for years. And to this day, no one on Earth knows what is sending it.
In this video, we are going to walk through exactly what scientists found. We'll cover why every single explanation they tried failed. We'll examine the 3 leading theories that exist today. And then, we'll get to the detail that has quietly divided the astronomy community. Because here's the thing, the object producing this signal should not be able to produce it. According to the laws of physics as we currently understand them, it is doing something impossible. Stay with me. Let's start with the facts. In January 2022, a team of astronomers led by Dr. Natasha Hurley-Walker at Curtin University in Australia published a paper in the journal Nature. In it, they described an object they had detected using the Murchison Wide Field Array, a powerful radio telescope network in outback Australia. The object, designated Gleam XJ1627, was producing enormous bursts of radio energy, 3 minutes long each burst, repeating every 18.18 minutes, with a brightness that, at its peak, made it one of the brightest radio sources in the entire sky. It was detected in archival data from 2018, and then it went silent. By 2022, when the paper was published, the signal had vanished, gone as suddenly as it arrived, leaving behind a mystery that has not been solved.
So what is it? The first thing scientists do when they find something unexplained in space is run through the checklist. Could it be a pulsar? Pulsars are rotating neutron stars that emit beams of radio waves like a cosmic lighthouse. They repeat, they pulse, they're well understood. But here's the problem. Pulsars spin incredibly fast, typically completing a full rotation in milliseconds to a few seconds. The fastest known pulsar spins 716 times per second. Even the slowest known pulsars take about 8 seconds per rotation. For a pulsar to pulse every 18 minutes, it would need to be spinning at a rate roughly 1,000 times slower than any pulsar ever observed. The physics of how a pulsar could spin that slowly and still produce radio waves does not currently work. A pulsar that slow should be dead, silent, invisible. So it's not a pulsar. At least, not a pulsar as we understand them. What else? Could it be a magnetar? Magnetars are a type of neutron star with an extraordinarily powerful magnetic field, 1 trillion times stronger than Earth's. They do occasionally produce radio bursts, but magnetar bursts are chaotic, irregular. They don't repeat at the precision of a Swiss clock every 18.18 minutes. Could it be a white dwarf? The collapsed remnant of a dead star? Possibly. This is actually one of the leading theories. But white dwarfs producing radio waves at this brightness have never been seen before. Every explanation scientists reach for requires us to revise what we thought was possible.
Stop. I want to make sure you understand what we just established. This is not a case of scientists finding something weird and then figuring it out. This is a case of scientists finding something that does not fit inside our current model of how the universe works. Not a gap in our knowledge, a contradiction. And the theories that have been put forward since are stranger than most people realize. Theory 1. The ultra-long period pulsar. In 2022, just months after the Gleam X discovery, the same research team found a second object. This one, designated GPM J1839, It was pulsing every 21 minutes. And here's what made the astronomy world go very quiet. When they searched archival data, they found this second object had been pulsing for 35 years. 35 years of data sitting in archives, unnoticed. A signal from deep space, repeating with metronomic precision for longer than the modern internet has existed. This changed everything. Because a one-time anomaly is a mystery. Two objects behaving the same impossible way is a class. There is now an entire category of astrophysical objects called ultra-long period transients that we cannot explain.
Theory 2. A white dwarf pulsar. Some scientists believe these objects may be white dwarfs, dead stellar cores with an unusually strong magnetic field. The idea is that as the white dwarf rotates slowly, its magnetic field sweeps a beam of radio energy across the cosmos every 18 to 21 minutes. This would explain the slow pulse rate. The problem? No white dwarf producing this kind of radio emission has ever been confirmed. We'd essentially be proposing a new type of object to explain an object we don't understand. Theory 3. A neutron star in an extreme state. A third group of scientists believes these are neutron stars in a theorized but never observed state, sometimes called the neutron star graveyard. Objects that should be too old and too slow to emit radio waves, but somehow aren't. The physics of why they'd still be active is not fully understood. And this is where it gets genuinely unsettling. Because by mid-2024, a third ultra-long period transient had been found, then a fourth. These objects are not rare anomalies. They are a population. A population of objects doing something our physics says they cannot do. And we are surrounded by them.
Remember the signal we described at the very beginning? Repeating every 18 minutes, precisely, from deep space. You now understand exactly how strange that is. Not strange in the way that most space facts are strange, distant, abstract, safe. Strange in the sense that something out there is doing something that challenges the equations. And we have found at least 4 of them. But here's the question no one has asked publicly yet. Why did the first one go silent? The silence is possibly the most important part of this story. Gleam X pulsed for roughly 3 months in 2018. Then it stopped. By the time the paper was published in 2022, it had not resumed. Whatever it was, it turned off. The working hypothesis among some researchers is that these objects have active windows, periods where conditions align to produce the emissions, and dormant periods where they don't. Like a cosmic lighthouse that occasionally turns off for years at a time. But this raises an uncomfortable implication. If these objects have active windows, there may be far more of them in the sky right now, in their dormant phase. Invisible, silent, waiting. And we would have no way of knowing. How many ultra-long period transients are there in our galaxy? Some estimates now suggest thousands, perhaps tens of thousands. A hidden population of objects doing something physically impossible, scattered through the Milky Way. Some of them right now, as you watch this video, pulsing toward Earth. Not detected, not yet named, but there. And here is the final detail that the researchers themselves have noted. The emission from these objects, at its peak intensity, is polarized, meaning the radio waves are not scattered randomly. They are organized, structured. This happens in known objects through specific physical mechanisms, rotation, magnetic fields. But the degree of polarization observed in some of these signals is unusually high,
unusually organized. No one is saying what the most uncomfortable theory is. No paper has used that word, but it is the word that sits quietly at the edge of every discussion. Every 18 minutes, precisely, for years, then silence. And we do not know why.
Science is, at its best, a process of replacing comfortable certainty with uncomfortable precision. We knew very little about the universe 100 years ago. We know vastly more today. And yet, every time we build a more powerful instrument and point it at the sky, it finds something we did not predict. Something that requires us to revise the equations. This is not a failure of science. It is the whole point of science. But it does mean something worth sitting with. The universe is not finished explaining itself to us. And somewhere out there, right now, a pulse is traveling toward Earth. Every 18 minutes. Exactly. And we still don't know who or what is sending it. If this video made you look at the sky a little differently tonight, there are more questions like this one on this channel. The next one asks a question that keeps cosmologists awake.
What was there before the Big Bang? In the last video, we walked to the very end of the universe. We watched the last star die. We watched the last black hole evaporate. We watched a single photon travel through a universe so empty it would never hit anything again. And we left you with one question. What was there before any of this existed? Before the Big Bang? Before space? Before time? Before the laws of physics themselves? What was there? The answer, depending on which physicist you ask, is either nothing, everything, something impossible, or a question that should not exist. All four answers are defended by serious scientists, and all four will change how you think about reality. In this video, we are going to walk through 4 theories. 4 serious, peer-reviewed, scientifically defended answers to the question of what existed before the Big Bang. Theory 1 will seem almost reasonable. Theory 2 will make you question whether time is real. Theory 3 proposes that our entire universe is a scar. And Theory 4, the one most physicists quietly find most compelling, suggests the question itself may be wrong. But before we get to any of them, we need to answer something simpler. Something that sounds simple, but is not. What is nothing? The Big Bang happened approximately 13.8 billion years ago. In an instant. Physicists mean instant, literally, a fraction of a second. All of space, all of time, all of matter, and all of energy came into existence. Not into a pre-existing empty space. Space itself was created in that moment. When we imagine the Big Bang, we picture an explosion happening somewhere, a fireball expanding outward into a surrounding void. That image is wrong. There was no surrounding void. There was no outside. The Big Bang did not happen in space. The Big Bang happened, and space came with it. Which means asking what was there before the Big Bang is like asking what is north of the North Pole. The question assumes something that does not exist. A before requires time, and time began at the Big Bang. So, is the question literally unanswerable? Not according to Stephen Hawking, Roger Penrose, Neil Turok, Lee Smolin, Max Tegmark. Some of the most rigorous minds in modern physics have proposed answers.
and their answers do not agree.
Let us deal with the nothing problem directly. When physicists say nothing, they mean the complete absence of everything. No matter, no energy, no space, no time. No laws of physics, no dimensions, no quantum fields. Absolute, total, complete nothing. Now here is the problem. Every time physicists try to model nothing mathematically, something appears. This is not a metaphor. Quantum mechanics tells us that a perfect vacuum, a region of space with nothing in it, is never actually empty. It seethes with virtual particles, pairs of matter and antimatter that pop into existence, annihilate each other, and vanish, constantly, everywhere, even in empty space. This is called quantum vacuum fluctuation, and it has been experimentally measured. It is real. Which means empty space, the closest thing we have to nothing, is actually full of activity. The Casimir effect proves this. Put two metal plates very close together in a vacuum. They will be pushed together by the pressure of virtual particles. Nothing pushing two things together, measured in a laboratory. So if even empty space is not nothing, what is nothing? And if true nothing cannot be physically achieved or mathematically modeled, does nothing exist? Has nothing ever existed? Could the universe have emerged from a nothing that was never truly nothing? This is where the four theories begin. Stop. Everything I just told you is what we know, experimentally confirmed, peer-reviewed, consensus physics. What comes next is what physicists propose, and some of it is going to feel like science fiction. It is not. These are serious, mathematical, published theories. And once you hear them, you will never think about existence the same way again. Theory 1. The quantum tunneling origin. Proposed by Alexander Vilenkin and independently by Stephen Hawking and James Hartle. This theory suggests the universe tunneled into existence from nothing. Quantum tunneling is real and well understood. It is how nuclear fusion works in the sun. A particle that classically cannot cross an energy barrier can quantum mechanically tunnel through it. Vilenkin's proposal is that the universe is the ultimate example of this. It tunneled into existence from a state of true nothing. The quantum probability of this tunneling event, though astronomically small, is greater than 0. Which means in quantum mechanics, it was not just possible, it was inevitable. Given infinite time, even in nothing, something must eventually appear. The problem? This still requires quantum mechanics to exist first. And quantum mechanics is a law of physics. Where did the law come from? Theory 2. The bouncing universe. Proposed by Roger Penrose, Paul Steinhardt, and Neil Turok, this theory says there was no before the Big Bang, because the Big Bang was not the beginning. It was a bounce. In Penrose's conformal cyclic cosmology, the universe is one cycle in an infinite series. At the end of each cycle, when the universe reaches maximum entropy, cold and empty, it becomes mathematically identical to a new Big Bang. The end of one universe is the beginning of the next. There is no first universe. There is no beginning. The chain extends backward infinitely. In the ekpyrotic model by Steinhardt and Turok, two vast membranes in higher dimensional space, called branes, periodically collide. Each collision is a Big Bang.
Our universe is the result of the most recent collision. Another cycle is coming.
Theory 3. The universe as a quantum fluctuation. Physicist Edward Tryon proposed in 1973 that the universe might be a quantum fluctuation, a temporary blip of energy that appeared spontaneously from the quantum vacuum. The total energy of the universe, if you add all matter and all gravity, is very close to zero, which is exactly what you would expect from something that came from nothing. The universe, on the cosmic balance sheet, costs nothing. Theory 4. The Hartle-Hawking no-boundary proposal. This is the one that makes physicists go quiet. Stephen Hawking and James Hartle proposed that the universe has no boundary in time, no beginning, not because something came before it, but because time itself changes shape near the Big Bang. Using imaginary time, a mathematical concept from quantum physics, they showed that as you approach the Big Bang, the dimension of time gradually becomes indistinguishable from a dimension of space. Asking what came before the Big Bang in this model is like asking what is south of the South Pole. The question does not fail because we do not know the answer. It fails because the geometry of reality makes the question meaningless. There is no before. Not because something is hiding it, but because time near the origin does not point backward.
Remember the question we could not answer at the start of this video? What is nothing? You now have 4 answers. Nothing is unstable, and the universe tunneled through it. Nothing never existed. There have always been universes. Nothing was a quantum vacuum, and one fluctuation got lucky. Or, nothing is a concept that does not apply, because time does not reach back far enough to contain it. These 4 answers cannot all be right. But here is the most disturbing possibility of all. What if more than one of them is?
The reason multiple theories might be simultaneously valid comes down to one concept: the multiverse. Not the Marvel version, not a narrative device. The mathematical consequence of quantum mechanics taken to its logical conclusion. If the universe can appear as a quantum tunneling event from nothing, there is no reason it happened only once. The same quantum probability that produced our universe applies equally everywhere, which means an infinite number of universes may have tunneled into existence, each one with potentially different physical laws, different constants, different rules. Most of them unable to form stars, planets, or life. Vast dead universes that expanded and cooled and produced nothing. And one of them, this one, happened to have precisely the right constants for hydrogen to form, for stars to burn, for carbon to be forged, for planets to cool, for chemistry to complexify, and for something on one small rock to look up and ask, what was there before this?
The reason there is something, rather than nothing, may not be a cause. It may be selection. We are not in this universe because it was chosen. We are in this universe because it is the kind of universe that produces things that can notice they are in a universe. This is the anthropic principle. Roger Penrose hates it. He calls it an intellectual cop-out. Max Tegmark considers it the natural consequence of mathematics. Lee Smolin has proposed that universes reproduce, that black holes give birth to baby universes, and that our universe's laws are fit because they evolved to be a cosmic natural selection. Through all of it, all four theories, the bouncing brains, the tunneling fields, one thing remains constant. We do not know. But the trying, the reaching of human mathematics into the space before space existed, is one of the most extraordinary things our species has ever attempted.
You are made of atoms. Those atoms were forged in stars. Those stars were born from the Big Bang. And the Big Bang came from something. Something we cannot see, cannot measure, and cannot fully describe. But the fact that we can sit here in this thin sliver of cosmic time and frame that question in precise mathematical language and propose 4 serious answers and hold the uncertainty with curiosity instead of fear is itself one of the stranger facts about this universe. The universe produced something that wonders where it came from. In the next video, we are going to take one of these theories apart completely. We are going to ask, if the multiverse is real, why can we not see it? And the answer involves some of the most controversial physics of the last 20 years. Subscribe to Microspace, and we will go find out together.